Hello, welcome back to prosimulation. In today's video, we are going to break down the complete refrigeration process used in the industrial gas treatment. We will look at how the system cools the gas, removes heavy components, protects equipment, and ensure a stable operation across multiple skids. This tutorial is designed for the engineering operator and anyone who wants a clear and technical explanation of how industrial refrigeration works. Let's begin. Section 1, Overview of the process. The refrigeration package we are analyzing is divided into several key skids. Each skid performs a specific function inside the overall cooling and separation process. The main objectives of the system are to cool the natural gas stream down to a target temperature, to condense heavier hydrocarbon and impurities, to stabilize the gas flow and pressure entering downstream unit, to protect the compressor and downstream equipment from liquid. Understanding how these components work together is essential for good process control and safe operation. Section 2, Skid 1, the primary heat exchanger. The first major component is the primary heat exchanger. Here, the inlet gas enters at relatively high temperature. Our goal is to remove as much heat as possible while maintaining a stable flow. Inside this exchanger, the refrigerant absorbs thermal energy from the gas. Depending on the cycle, this could be propane-ethylene mix refrigerant or any other industrial cooling medium. As the refrigerant evaporator, the gas cools down significantly. This is the first and most important cooling step because it prepares the gas for the condensation of heavier fraction later in the process. Section 3, Skid 2, the separator. Once the gas exits the heat exchanger, it flows into the cold separator. This vessel plays a critical safety and efficiency role. It removes any liquid droplet formed during cooling. It prevents downstream equipment from receiving liquid slugs. It stabilizes two-phase flow. The top of the separator sends dry cold gas to the next skid, while the bottom collects liquid condensate, which is routed to a drain or a stabilization system. Proper level control in this vessel is extremely important. Incorrect tuning can easily lead to compressor trips or unstable operation. Section 4, Skid 3, the compressor and suction system. Next, we move into the compressor skids. At this point, the gas pressure must be increased so that it can be continue circulating throughout the refrigeration loop. Key components include the compressor, which increases the pressure of the refrigerant or process gas, suction scrubber, which provide extra filtration of any remaining liquid, anti-surge control system, which protect the compressor during unstable flow condition. If the separator performs poorly, liquid may enter this skid. This is extremely dangerous because liquid droplet can severely damage compressor plates. Therefore, compressor always include multiple protective layers. such as differential pressure monitoring, level controller, and fast acting shutdown valve. Section 5. Skid 4. The condenser and receiver. After compression, the refrigerant now carrying significant heat. It must be cooled and condensed before returning to the evaporator. This is handled in the condensate skids. The condenser rejects heat to the environment using air coolers, water heater, shell and tube condenser, depending on the system design. When the refrigerant condensed into liquid, it accumulated in a receiver tanks. From here, it flows back through expansion valve into the evaporator or heat exchanger, closing the cycle. The goal of this skid to maintain stable refrigerant inventory and constant cooling capacity. Section 6. The complete cycle. Now we have analyzed each skid individually. Let's summarize the full refrigeration loop. First, gas enters the heat exchanger and loses heat to the refrigerant. 2. Cooled gas flow into the separator where liquid are removed. Then gas entered the compressor skid where pressure is increased. Hot refrigerant flow into the condenser, released heat and become liquid again. Liquid refrigerant expand and return to the heat exchanger. The cycle repeats continuously. This closed loop system ensures efficiency cooling of industrial process gas stream. Section 7. Why this matters? Refrigeration packages are essential in the industrial such as natural gas processing, LNG pre-treatment, petrochemical plant, CO2 capture and purification, also biomethane upgrading. Proper understanding of this system helps engineering improve plant efficiency, prevent equipment failure, optimize energy consumption, enhance product quality, also reduce safety risk. That is why modeling, simulation, and good control strategy are so important. Thank you for your attention.